We are Team Warfare 683A from Taipei, Taiwan, and this is our VRSkills code explanation video. Our code is composed of 5 parts: built-in class constructors, constants, helper function definitions, class definitions, and execution. The first part contains the basic objects built-in in VRSkills. The constant part contains shared variables that do not change, such as coordinates of the high goal. The helper method definitions part defines the small helper functions that can be used throughout the code. The class definitions part defines a series of classes for use. In particular, we implemented 2 design patterns there: singleton and facade. Singleton is used in every robot component class since the robot does not contain multiple components of the same type. Facade is implemented to make development easier by grouping the components together and create a nice and clean interface with a master class. The last part declares a custom robot object and runs autonomous routes. For locomotion, we use GPS to track the position and the rotation of the robot on the field. We utilize this to achieve various movements. Firstly, in the chassis class, we made a function called face angle. It allows the robot to rotate to a specific absolute orientation. Secondly, we also created a face coordinate function. The function calculates the angle of rotation and rotates the robot to face a specific coordinate on the field. This allows accurate high-goal aimings everywhere on the field. Additionally, we made a move-to-point function that accepts coordinate inputs and moves the robot to a specific point. It allows us to program the robot to move to anywhere in the field with ease. We also created a function called move to point backwards. We added 180 degrees to the target rotate angle and changed the direction of the translational movement to the opposite. We also use an optical sensor to detect rollers nearby, ensuring that the robot approaches to a roller from the same distance so that no rollers are missed. Lastly, the robot needs to shoot this accurately and fast to score points in a short period of time. To do this, we use 3 line trackers located on the intake to check whether all discs are shot in the shooting process, and the robot can immediately start the next movement after all discs are shot. Through this challenge, we learned the concept of sensor fusion, combining 3 line trackers to effectively detect discs in the robot's intake. In the development of the code, we learned various design patterns and applied the fittest design patterns in our project to maintain sustainability and scalability. On many occasions, mistakes such as intake misses can happen. To tune our program to the most efficient, we learn effective debugging techniques such as backtracing and problem simplification to identify issues and fix them.